The National Electrical Code, or NEC, does not contain specific requirements related to the height of receptacles when they are installed above lay-in ceilings. However, it's important to understand that while the NEC sets a baseline for electrical safety, it's not the only set of rules you need to follow. Potential violations could arise from local building codes or other applicable regulations in your specific jurisdiction. These local rules might have more stringent requirements or specific prohibitions regarding the placement of electrical receptacles above suspended ceilings. Therefore, it's crucial to check with your local authorities or building inspectors to determine if installing receptacles in this manner is permitted in your area. Aside from code compliance, several practical considerations should inform your decision regarding receptacle placement. One of the primary considerations is accessibility. Receptacles installed above lay-in ceilings are inherently difficult to access for maintenance, repairs, or even routine use. This inaccessibility can create safety hazards when attempting to plug in or unplug devices, especially if the ceiling is high or requires the use of a ladder. It's also worth noting that accessing receptacles above a lay-in ceiling might necessitate removing ceiling tiles, which can be disruptive and potentially damage the tiles. Another important aspect to consider is safety. If a fault occurs in a device plugged into a receptacle above the ceiling, it may be difficult to quickly disconnect the power source. This delay could increase the risk of electrical shock or fire. Furthermore, any loose wiring or connections above the ceiling could pose a hazard if not properly secured and insulated. Given these considerations, a recommended practice is to install receptacles below lay-in ceilings whenever possible. This approach ensures that receptacles are easily accessible and within reach of occupants, simplifying maintenance and reducing the risk of accidents. When receptacles are installed below the ceiling, they can be conveniently used without the need for ladders or the removal of ceiling tiles. Furthermore, it's easier to visually inspect the receptacles and wiring for any signs of damage or wear. If installing receptacles below the lay-in ceiling isn't feasible due to space constraints or other project-specific factors, several alternative solutions can be explored. One option is to install receptacles on walls or partitions at a convenient height. This approach provides easy access and avoids the challenges associated with above-ceiling installations. Another alternative is to use power strips or extension cords to bring power from a more accessible location to the desired point of use. However, it's essential to use these devices safely and in accordance with manufacturer instructions. Avoid overloading power strips and ensure that extension cords are properly rated for the intended use. Also, remember to inspect the cords regularly for any signs of damage. When installing electrical boxes and conduits above a lay-in ceiling, it is imperative to adhere to all applicable codes and regulations. This includes using appropriate wiring methods, securing the boxes and conduits properly, and ensuring that all connections are made correctly. It's also recommended to label the electrical boxes and conduits to indicate their purpose and voltage. This can help prevent confusion and reduce the risk of accidents during future maintenance or repairs. In summary, while the NEC doesn't explicitly prohibit receptacles above lay-in ceilings, it's crucial to consider local codes, accessibility, and safety when making your decision. In most cases, installing receptacles below the ceiling is the preferred approach. If this isn't possible, explore alternative solutions and always ensure that all electrical work is performed in accordance with applicable codes and regulations. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns. They can provide expert guidance and ensure that your electrical installation is safe and code compliant. Let's dive into more details concerning the considerations involved with receptacle installations in relation to lay-in ceilings. Firstly, local building codes and regulations deserve close attention. The NEC provides a comprehensive set of guidelines for electrical installations, but it serves as a foundational standard. Local jurisdictions often adopt and amend the NEC to address specific regional needs or concerns. These amendments can introduce stricter requirements or outright prohibitions regarding certain electrical practices, including the placement of receptacles above lay-in ceilings. To ensure compliance, it is essential to consult with your local building department or electrical inspector before commencing any electrical work. They can provide you with the most up-to-date information on applicable codes and regulations in your area. Secondly, accessibility plays a vital role in the safety and functionality of electrical systems. Receptacles installed above lay-in ceilings are inherently difficult to access for routine maintenance, repairs, or troubleshooting. This inaccessibility can create several challenges. For example, if a receptacle malfunctions or requires replacement, accessing it may involve removing multiple ceiling tiles, which can be time-consuming and disruptive. Moreover, working above a suspended ceiling can be hazardous, particularly if the ceiling is high or the space is confined. There is also a risk of damaging the ceiling tiles or other components of the suspended ceiling system during access. Thirdly, safety is a paramount concern when dealing with electrical installations. Receptacles installed in hard-to-reach locations can pose safety hazards, especially in emergency situations. For instance, if a device plugged into a receptacle above a lay-in ceiling malfunctions and starts emitting smoke or sparks, quickly disconnecting the power source may be difficult. This delay could increase the risk of fire or electrical shock. Furthermore, any loose wiring or faulty connections above the ceiling could create a potential ignition source. Fourthly, practical considerations often dictate the best approach to receptacle placement. In many cases, installing receptacles below lay-in ceilings is the most practical and convenient option. This allows occupants to easily access the receptacles without having to climb ladders or remove ceiling tiles. Receptacles installed at a standard height are also more accessible to people with disabilities, promoting inclusivity and usability. Fifthly, alternative solutions should be explored when installing receptacles below lay-in ceilings is not feasible. One common alternative is to install receptacles on walls or partitions at a convenient height. This provides easy access and avoids the challenges associated with above-ceiling installations. Another option is to use surface-mounted raceway systems to route wiring and install receptacles along walls or ceilings. Surface-mounted raceways are aesthetically appealing and can be easily modified or expanded as needed. Sixthly, code-compliant wiring methods are essential for ensuring the safety and reliability of electrical installations. When installing wiring above lay-in ceilings, it is important to use wiring methods that are approved for this type of application. Common wiring methods include electrical metallic tubing, or IM, flexible metal conduit, or FMC, and cable assemblies specifically designed for use in plenum spaces. All wiring must be properly supported and secured to prevent sagging or damage. Seventhly, proper support and securement of electrical boxes and conduits are crucial for maintaining the integrity of the electrical system. Electrical boxes must be securely mounted to structural elements of the building, such as ceiling joists or framing members. Conduits must be properly supported using conduit clamps or hangers at intervals specified by the NEC. This prevents the conduits from sagging or becoming dislodged, which could damage the wiring and create a safety hazard. Eighthly, labeling of electrical components is a best practice that can significantly improve the safety and maintainability of electrical systems. Electrical boxes and conduits should be clearly labeled to indicate their purpose and voltage. This can help prevent confusion and reduce the risk of accidents during future maintenance or repairs. Labels should be durable and easy to read even in low light conditions. Ninthly, qualified professionals should always perform electrical work. Electrical work should only be performed by qualified electricians who have the necessary training, experience, and knowledge of applicable codes and regulations. Attempting to perform electrical work without proper training can be dangerous and may result in serious injury or property damage. Tenthly, regular inspections and maintenance are essential for ensuring the long-term safety and reliability of electrical systems. Electrical systems should be inspected regularly by a qualified electrician to identify any potential problems or hazards. Maintenance tasks, such as tightening connections and replacing worn components, should be performed as needed to keep the electrical system in good working order. Considering specific code requirements, the NEC addresses wiring methods above suspended ceilings in Section 300.22, which covers wiring in ducts, plenums, and other environmental airspaces. A plenum is defined as a compartment or chamber to which one or more air ducts are connected and that forms part of the air distribution system. If the space above a lay-in ceiling is used as a plenum for environmental air, then the wiring methods must comply with section 300.22c. This section typically requires the use of plenum-rated cables and wiring methods to minimize the spread of fire and smoke in the event of a fire. Common plenum-rated cables include CMP-rated cables, which are specifically designed for use in plenum spaces. These cables have a low smoke and flame spread rating, which means they are less likely to contribute to the spread of fire and smoke in a building. Section 314.23 of the NEC covers the requirements for the support of boxes and conduit bodies. This section specifies how electrical boxes and conduit bodies must be supported to ensure they remain securely in place. Electrical boxes must be securely fastened to structural elements of the building, such as ceiling joists or framing members. Conduit bodies must be supported using conduit clamps or hangers at intervals specified by the NEC. The specific requirements for support spacing depend on the size and type of conduit. Section 406.4 of the NEC covers the requirements for the installation of receptacles. This section specifies the minimum height at which receptacles must be installed above the floor or working surface. While the NEC does not specify a maximum height for receptacles, it is generally recommended to install them at a convenient height for occupants to access. Receptacles installed too high may be difficult to reach and could pose a safety hazard. Section 406.5 of the NEC covers the requirements for the grounding of receptacles. This section requires that all receptacles be properly grounded to protect against electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. This helps to prevent electrical shock in the event of a ground fault. Considering specific products and equipment, various types of electrical boxes are available for use above lay-in ceilings. These include metal boxes, non-metallic boxes, and adjustable boxes. Metal boxes are typically used for applications where strength and durability are required. Non-metallic boxes are lightweight and corrosion resistant, making them suitable for use in damp or corrosive environments. Adjustable boxes allow for flexibility in mounting depth, which can be useful when working with varying ceiling heights. Various types of conduits are available for use above lay-in ceilings. These include EMT, FMC, and rigid metal conduit, or RMC. EMT is a lightweight and versatile conduit that is easy to install. FMC is a flexible conduit that can be used in tight spaces or where vibration is a concern. RMC is a heavy-duty conduit that provides excellent protection against physical damage. Plenum-rated cables are specifically designed for use in plenum spaces. These cables have a low smoke and flame spread rating, which means they are less likely to contribute to the spread of fire and smoke in a building. Common plenum-rated cables include CMP-rated cables and CL2P-rated cables. Receptacles specifically designed for use in commercial or industrial settings are often used above lay-in ceilings. These receptacles are typically more durable and offer better performance than residential-grade receptacles. They may also include features such as tamper-resistant shutters or surge protection. Let's consider best practices for receptacle installations above lay-in ceilings. Firstly, minimize receptacle installations above lay-in ceilings whenever possible. Installing receptacles below lay-in ceilings is generally the preferred approach. This provides easy access and avoids the challenges associated with above-ceiling installations. Secondly, consult with local authorities to determine applicable codes and regulations. Local building codes and regulations may have specific requirements or prohibitions regarding the placement of receptacles above lay-in ceilings. Consult with your local building department or electrical inspector before commencing any electrical work. Thirdly, use plenum-rated cables and wiring methods in plenum spaces. If the space above a lay-in ceiling is used as a plenum for environmental air, then the wiring methods must comply with section 300.22c of the NEC. This section typically requires the use of plenum-rated cables and wiring methods. Fourthly, securely support electrical boxes and conduits. Electrical boxes and conduits must be securely mounted to structural elements of the building to prevent sagging or damage. Use appropriate support hardware and follow the manufacturer's instructions. Fifthly, label electrical components for easy identification. Electrical boxes and conduits should be clearly labeled to indicate their purpose and voltage. This can help prevent confusion and reduce the risk of accidents during future maintenance or repairs. Sixthly, use tamper-resistant receptacles in accessible locations. Tamper-resistant receptacles have shutters that prevent the insertion of foreign objects, reducing the risk of electrical shock. These receptacles are required in certain locations, such as childcare facilities and healthcare facilities. Seventhly, install ground fault circuit interrupter, or GFCI, protection in wet or damp locations. GFCI protection is required for receptacles installed in wet or damp locations, such as bathrooms, kitchens, and outdoor areas. GFCI receptacles protect against electrical shock by detecting ground faults and quickly interrupting the circuit. Eighthly, use arc fault circuit interrupter, or SI, protection in dwelling units. SI protection is required for receptacles installed in dwelling units to protect against electrical fires. SI circuit breakers detect arc faults, which are a common cause of electrical fires, and quickly interrupt the circuit. Ninthly, perform regular inspections and maintenance. Electrical systems should be inspected regularly by a qualified electrician to identify any potential problems or hazards. Maintenance tasks such as tightening connections and replacing worn components should be performed as needed to keep the electrical system in good working order. Tenthly, consult with a qualified electrician for complex installations. Complex electrical installations should be performed by a qualified electrician who has the necessary training, experience, and knowledge of applicable codes and regulations. Attempting to perform complex electrical work without proper training can be dangerous and may result in serious injury or property damage. Let's further delve into specific scenarios and examples related to receptacle installations above lay-in ceilings. Consider an office building where receptacles are needed to power computers and other equipment. If the space above the lay-in ceiling is used as a plenum for environmental air, then plenum-rated cables and wiring methods must be used. The receptacles should be installed in accessible locations, such as on walls or partitions, whenever possible. If receptacles must be installed above the lay-in ceiling, they should be securely supported and labeled for easy identification. Consider a retail store where receptacles are needed to power display lighting and point-of-sale systems. The receptacles should be installed in tamper-resistant receptacles in accessible locations to prevent the insertion of foreign objects. GFCI protection should be provided for receptacles installed in wet or damp locations, such as restrooms or break rooms. If receptacles must be installed above the lay-in ceiling, they should be securely supported and labeled for easy identification. Consider a healthcare facility where receptacles are needed to power medical equipment and patient care devices. The receptacles should be installed in tamper-resistant receptacles in accessible locations to prevent the insertion of foreign objects. Hospital-grade receptacles should be used for critical medical equipment. If receptacles must be installed above the lay-in ceiling, they should be securely supported and labeled for easy identification. Consider a school where receptacles are needed to power computers, projectors, and other educational equipment. The receptacles should be installed in tamper-resistant receptacles in accessible locations to prevent the insertion of foreign objects. SI protection should be provided for receptacles installed in classrooms and other learning areas. If receptacles must be installed above the lay-in ceiling, they should be securely supported and labeled for easy identification. The use of specific tools and equipment can greatly enhance the safety and efficiency of receptacle installations above lay-in ceilings. Firstly, a cable puller can be used to pull cables through conduits, reducing the risk of strain or damage to the cables. Secondly, a conduit bender can be used to bend conduits to the desired shape, allowing for precise routing of wiring. Thirdly, a wire stripper can be used to remove insulation from wires without damaging the conductors. Fourthly, a crimping tool can be used to crimp connectors onto wires, creating a secure and reliable connection. Fifthly, a multimeter can be used to test the voltage and continuity of circuits, ensuring that the wiring is properly installed and functioning correctly. Sixthly, a ground fault circuit interrupter, or GFCI tester, can be used to test the operation of GFCI receptacles, ensuring that they are providing adequate protection against electrical shock. Seventhly, an arc fault circuit interrupter, or RFSI, tester can be used to test the operation of RFSI circuit breakers, ensuring that they are providing adequate protection against electrical fires. Eighthly, a voltage tester can be used to verify that circuits are de-energized before working on them, reducing the risk of electrical shock. Ninthly, a ladder or scaffolding can be used to safely access receptacles and wiring above lay-in ceilings. Tenthly, personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools, should be used to protect against electrical hazards.